If we were in a face-to-face class, I would spend more time on rocks. I would pass them around. There would be rock identification. Rocks are a very visual, very tactile thing, but we're not. We're in an online setting. So I focus on other things and add more time to other subjects. But rocks are important to understand, at least generally. We're going to go through them. Rocks are a combination of minerals and or organic material that are classified into three groups: igneous rocks, sedimentary rocks, and metamorphic rocks. We're going to begin with the igneous rocks. Igneous rocks solidified from the liquid state. That means they were so hot they liquefied. And we classify igneous rocks into two groups: intrusive igneous rocks and extrusive igneous rocks. Intrusive igneous rocks solidified below the surface, in other words, inside the planet, from magma. Magma is just liquid rock inside the planet. When it comes out onto the surface, we change its name to lava or pyroclastic material. So this is a geographical locator. When you say magma, you mean the stuff that's inside the planet. When you say lava, it's the stuff that's outside the planet, okay? So intrusive igneous rocks solidified below the surface from magma. Because the planet acts as like an insulator in a way, intrusive igneous rocks cool slowly. Extrusive igneous rocks solidified from lava and pyroclastic material. Lava is liquid rock that is flowed out onto the surface. Pyroclastic material is the stuff that gets blown up into the air during an eruption. You've all seen pictures of or watched videos of a volcanic eruption. You know that it's not just lava coming out, stuff gets thrown into the air. That stuff that gets thrown in the air is called pyroclastic material. Extrusive igneous rocks cool very rapidly because of their contact with the atmosphere, because the atmosphere is significantly cooler than the interior of the planet. Now, it may be a warm day, but that's not warm compared to what's going on inside the planet, obviously. So extrusive igneous rocks cool very quickly. Intrusive igneous rocks cool slowly. Sedimentary rocks are rocks that are made up of broken down and weathered former rocks and or organic material. And they're solidified through compaction and or chemical cementation. Sedimentary rocks form in layers, horizontal layers, as you're going to see shortly when I talk about the tectonic processes. So when you see flat layers, horizontal, parallel to each other, those are almost certainly going to be sedimentary rock. Not 100%, but mostly. We call those layers strata, which is the Latin word for layers. One of the ways that sedimentary rocks can form is if you pile up a bunch of material, and over time there's an increasing amount of weight as you continue to pile material up. The material that's down at the bottom gets compressed down, and when it does that, it can form together. It's a little bit like if you took a loaf of white bread and stood it up, all sliced in its 20 slices or whatever a loaf of white bread comes in, took your hand and then pressed down on the crust and smashed that loaf of white bread down onto a table. Instead of having 20 slices, it would just be one single solidified slice. That's kind of what happens with sedimentary rocks in a way. Metamorphic rocks are formed from previously existing rocks, in other words, igneous rocks, sedimentary rocks, even other metamorphic rocks that have been altered through extreme amounts of heat and or pressure. I would put it like this. You have probably made a cake at some point in your life. When you make the cake batter, it's all this liquidy stuff. You put it into the oven, you heat it up. When you pull the cake out, it is something different. Chemically the same thing, but physically it has been altered. Metamorphic rocks are going through a similar thing. You add all of this heat and pressure, but don't melt them. But if you add all of this heat and pressure, you change the rock. For example, limestone, which is a sedimentary rock, when it goes through the metamorphic process, turns into marble. There's something called the rock cycle, which basically describes this. Any one type of rock can become any other type of rock under the right circumstances. So if you had sedimentary rocks or metamorphic rocks and you wanted to turn them into igneous rocks, all you do is melt them. Once they liquefy, when they re-solidify, they're igneous rocks. If you have igneous rocks or metamorphic rocks and you want to turn those into sedimentary rocks, you break them down into smaller pieces, which you can see in that diagram on the right-hand side where it says sediment. It's like sand. You pile them up and then compact them or cement them. And if you want to make metamorphic rocks out of igneous rocks, sedimentary rocks, or other metamorphic rocks, you heat them up, you cook them, but don't melt them. Because, of course, when you melt them, you turn them into igneous rocks.